Hello, my name is Joshua Goddess, and I'll be going over the framework that my team and I made. What we built was a static analysis tool framework written all in C. What this does is it allows you to run multiple static analysis tools such as Cppcheck and Flawfinder, and it will generate one cohesive report. This just saves you the hassle from juggling multiple different outputs from the different source files or from the different tools. Just this project, which we're calling Framework SAT or SAT, just normalizes everything into one single data model. It correlates findings across all the tools, and it allows you to use both the command line and a graphical interface to see these results. If you were there for the live demonstration, we showed off the GUI. I am currently on my dev server here, so I can't show off the GUI. I'm just remoted into this, so I'll just show off the terminal interface here. The problem that we're trying to solve is programmers, as programmers, there's vulnerabilities in our code, especially with low-level languages like C and C++. There's problems with our code. I can show you an example of some problems with some code here. We have this kind of test.c here, and this code is pretty messy. We have a memory leak here. Just this pointer isn't freed. We set a buffer to 10, and then we can easily exploit that buffer with a buffer overflow. We have this X here, which is not even initialized. There's nothing. We're trying to compare something, and it just doesn't. There's nothing to compare. And then we have a null pointer dereference. So we just set this pointer to null, and then we try setting 5 to it. If you know anything about memory management, this is no bueno, no bueno. This is a really bad program, but it actually compiles. With it compiling, someone who's untrained would think like, oh, hey, the program works, right? But as programmers, we know that this code has some problems. What happens if we are in a big code base, right? This was a pretty small file. We can point out these errors really easily, these vulnerabilities, if anything. We were able to point it out pretty easily. But what if you're in a really big a code space, right? And you see these small little ones, little vulnerabilities that creep in. It's hard to find them. So we have some tools, as I mentioned, Cppcheck, Flawfinder. We also are using Coverity, and then with GCC's built-in analyzer. So we'll be using these 4 tools for this project. What we want to do is to run each one of these tools in parallel and actually create an output. We're using Clang to compile everything. As I said, this is all written in C for speed. If you are a person who wants to use these tools, but you don't want to spend all the time like reading the outputs, comparing the outputs, time is of the essence to you. So that's why we didn't use Python or another programming language that can slow it down. We just went for C, just bare C, runs really quickly, and I'll show you with the terminal right now. So we're using make to orchestrate everything, just to make things our lives 10 times easier. I already, this is actually take number 3 of this video. So I already have things already built. So we can just we have a method here, make clean, and it'll actually remove everything. And then we can just do make again, and there we go. Everything's compiled. It's very quick. It's a lightweight framework. So how it works is you just kind of go into your build, pretty standard, and then you just go into your analyzer. That's what it is. It's named. You will also see a GUI, SAT-GUI that would be your GUI version of this. But we're going to use the TUI version today for this demo. So, so our argument that we want to pass is the actual file that we want to check. So for this one, we're just going to do test.c. In the live demo, we did a GIMP. We actually took a section of GIMP, the open source software, and we ran it through our tool. It didn't find anything. It did give some warnings, but that was just something that it wasn't severe, or it didn't even like show up anything. But yeah, okay. So as you saw, it was really quick. So this here is our report that was created. This is actually what the text file looks like here. So Coverity did not run. As I said, I'm on a server. Coverity, you need to actually install it, like the executable from the website. It's a little difficult to do on a server, but I do have Cppcheck, Flawfinder, and GCC installed. And this is actually just a good test case with a tool that's uninstalled. The program does not fail out. It still runs. Everything runs. It just skips over that program if it can't run anything. So it found a total of 13 vulnerabilities. And then it'll break it down into each category. There's 4 high, 0 critical though. So I wonder how we can get it to a critical. I have not seen critical yet. And I tried the test.c, as you saw, in a C++. But yeah, let's view. Let's go in and let's view this analyzer. So it puts it in the report, so you can have the choice of JSON or the TXT. I'm just going to open up the TXT here. So it creates it with the date, the time, and then the target of the file. So let's see, Cppcheck. All right. It found the memory leak, the pointer that did not get freed. It found the dereference. It also found the uninitialized variable here. What's interesting is Flawfinder finds the same one here. The reference, where is it? Here we go. Flawfinder high, and then it finds the same one. Oh, there we go. So these two are the same. Here in the GUI, you're able to see the confidence levels and everything like that. Where if you click in each individual one, you will see that Flawfinder also found the same one. And here we go. And the GCC also found the same one. The value X is never been initialized. So yeah, that's the project. Creates a text file and a JSON. JSON's really, we can show the JSON here. It finds this. It's readable. It's pretty readable. It just kind of takes the output of everything. I see this more or less being used to be thrown into like some kind of like generative AI. And then you just kind of like say like, okay, here's the problem with it. Here's everything. And then have like the generative AI like go in and kind of like clean it up. This code from this one file. Text file is more for like human readable things. So I'm gonna go over kind of like our architecture. SAT or framework SAT is built as a pipeline. So it kind of starts out with the runners. The runners run each tool in a separate process. But the processes do run in parallel just for the added speed. So Cppcheck invokes with a .xml. So it will, the XML flags will create an XML file, and then Flawfinder will do a CSV file, and then the GCC just runs the fanalyzer. So let's kind of get into that. Bear with me as I open up a NeoVim here. So here's our include. We can kind of start at the top. Our logging here, this was mainly for us to debug. A lot of this code is removed, like these macros. We don't use these macros anywhere. And then this is just set for kind of figuring out what goes on at the background when we were having issues running into like the. I remember running into like the runner with Cppcheck. There was some issues, and we just had to like figure out like logging, like, hey, this is what's happening. Where's it failing out at? So yeah, these are our types. In C, we don't really have access to a lot of types unless we import this this library here, this std int. So yeah, so we were able to take in like a 8-bit integer. These are signed integers here, all the way up to 64, and then the unsigned. We just did type def and renamed them to U8 and then I8 respectively. And then going down the list, of course, as you see here. This is I like the I don't like typing out like UN64 underscore type or dash or underscore T. You know, it's very long. I like how Rust kind of names everything, so I just kind of match that there. We also have a enum here with the tool ID, which kind of goes into Cppcheck, Flawfinder, GCC, and Coverity. These are the tools that we're using. And then the count is like the amount of tools that are ran. We see that in the GUI where you can select the amount of tools. And then for the TUI, when it actually creates everything, you can see like the count as you saw before. So the severity here, this enum, we had to make our own mapping because each tool kind of gives its own output, right? So we wanted to be able to map everything to the specific output, and make like a common language so it's readable to everybody. And that's what these that's what this enum does. So and we have this finding here, this finding strut. What it does is you take in your tool, you take in the file that you're doing, and then your target file, right? And then you kind of go through, and then you just look at the line in the colon where the message is created, and then you will take in the severity, and we map each severity to a specific corresponding based on like the tool output, and then we get the category and the message. So that's what this strut does. Very simple. Our utils, this is just for basic like strings, and then like findings and freeing all those findings. This is just to help out with, this is more of less of a helper functions more than anything. This is more the nitty gritty and the core. So we have our correlation here. Our correlation takes in our findings, and it will kind of like put it in a struct that we can use to generate the report. So we take in our tools, and then we take in each each report from each tool, and then that will give us the severity of each tool and each category and message that it generates. And then as we move down, like we have our correlation findings, which this is the item, so this is the actual results. So we got the findings, right? Now we're going to turn it into the results. So we take each and every item that was generated, we get the count, and then we get the capacity. I had to throw in capacity here to help prevent like from buffer overflows. Just because like if someone puts in a really long file, which may compile, but it's just so big that it's just kind of they're just to try to crash the program, right? So I just added a capacity in there, and then it just kind of rejects like those kind of bigger files there. And then this is our correlation results, so it will take in our findings list, and then just our free, so we can clean everything up after we're done. So we're creating a database. It's not like it's not like an actual like SQL database or anything like that. It's just something there to store, like more like Excel. Just to store everything, and then just once the report's made, just get rid of the database. It's just more of a storage bin right? So we're going to put all the findings inside this database, all the correlation results, the files, and then like the file count. This tool allows you to do directories, the whole directories. Uh, Not really recommended because there can be a lot of overlap with some files and like things, so it can make the report very messy. However, it is possible, and it will kind of say like, okay, these are all the files, this is all of this, and then it will generate the report just fine. I just found it easier to write it, do one file at a time. So this is our findings. So it just kind of goes through and gets all of the findings from the report, and then this is these two are for the GUI. We can filter out each tool, and then we can filter out each severity. Again, if you were there during the live demo in class, you were able to see the filtering being used. We have a scoring too, and this is also mainly used in the GUI, where you're able to map different vulnerabilities that are found, and then it will say like, if Cppcheck finds this one, it'd be like, oh, Flawfinder also found this, kind of like in like little in the toolbar at the bottom. So for the GUI, we used Raylib. Raylib is a C library. There's a lot of information about it, and you're able to kind of build up a framework pretty easily using it. That's why we did use it. So that's really all we did. It was just very simple GUI. We have our model here, which will create the actual the apps inside the GUI, and then we have the UI, which will set up the window, and then the frame with inside there, which then it goes back into the model, and then this is everything you will see in here. It's not too complicated. Just there's a lot of resources out there for Raylib already. This is the more important section. These three here: our parser, our runner, and our report. I want to start with the runner because I find that this is a good starting point. Each runner is the same and how it works. So basically, all it does is it runs the Cppcheck as a system call. So it will go in, and then it's almost like you're in a terminal interface, right? So you just do a system call with that specific one. Let's open up. Actually, this will be a good point to go into the source here. So let's open up runner. Let's go into Cppcheck. Here we go. Okay, so we have Cppcheck here, and then it will take in our source file, and then we need an output file here. So our output file is going to be a XML, and that's the report that the Cppcheck will make. So we take in Cppcheck, we say XML version 2. We're going to enable everything, and then we're going to suppress missing include systems. So for example, if we have like a Raylib included, but we don't have like that Raylib header or anything like that in there inside the our toolkit, it's not gonna complain about it, right? It's gonna be like, okay, you're pointing somewhere else, yeah, but I want to look at this specifically. So it's not gonna go down like this rabbit hole and like check for everything. I do want to point this out here. I found this pretty interesting. So in Flawfinder, we're running it as a CSV. I had to add this hyphen here because with Flawfinder you can actually put in more more sub processes or just more files, right, with inside of this particular sub process. Our GUI can handle multiple files, but what it does, it spins up like a new instance of Flawfinder. But like Flawfinder by itself, you can actually add like 3 or 4 files in at once. So I had to add in this hyphen, so that way it doesn't go past its intended use. We want Flawfinder, Cppcheck, Coverity, and GCC to run one file at one time. We don't want it to take in multiple files and like confuse the report or anything like that. So I had to add in this hyphen here, and that actually stops everything past it. So you can't add multiple files. I found that pretty interesting. But yeah, so it will take in this runner here. So this run tool, and then this is the actual thing for it. So this is the Windows. Windows is not happy when it comes to this runner stuff. But for the Linux side and the Unix side, it's great. It works great. Windows is still it still works. It's just the report can be a little iffy running Cppcheck and GCC just because how Windows is. Like, it doesn't come with GCC. It's this is like getting off on a tangent, but it really does infuriate me that Windows does not come with GCC. So there's a lot more that we had to do for it to make it cross-platform, but it does work. We tested it out on Windows. It's just there's some nitty-gritty stuff. But yeah, so sorry about that. So we had the run tool, and then the tool here. So we've taken the tool that we're using. So if, for example, we'll just say Cppcheck, and then we'll take in our arguments, and then we'll take in our output file. So if we go back to Cppcheck, so here we go. We take in our Cppcheck. That's the ID of it. We're going to take in our args, which is this here, and then our output file. So, and then our output file would just be that XML that gets created. So you just create a PID, right? And then you will open up this output file, the XML in this case for Cppcheck. And then if it fails to open, it just fails. And then it will output. It will just do std out file, which would just be everything that it finds the output, and then just puts it all in here, and then it will exit once everything is done. And if it fails out, if it can't run or something like that, it will just say, hey, executable failed. And we actually saw that Coverity failed to run because it was never installed. So now we have our parser. I'm going to go back into Cppcheck here. So it's going to parse the output of this XML. So this is the main part here. This static function. It's going to take in the severity of everything. So we had to kind of find what does Cppcheck give? It gives error, warning, style, performance, and information. So if it outputs something that we don't know, we're just going to set it as a severity unknown. We still want to report it, but we don't know the severity of it. If we get an error, it's going to be severity high. If we get a warning, we're going to say that's a medium. And if it's style, performance, those are kind of like low. They still need to be reported, but it doesn't really affect the program. Maybe performance a bit, but like how you style it and things like that, that is a low severity. And then we have like an information. So if you get like some kind of like compiler warning or something like that, depending on the information that's being given, it can be either taken as a warning or it can be taken as information. I've seen a lot more warnings get thrown into information using Cppcheck, which some of them were good catches, were general good catches. And honestly, I thought it should be more of a warning, but Cppcheck, how it's initially designed, did not think so. But that's okay. The report still reported it, and I was able to fix that there. So we have our parse.cppcheck. So it's going to parse the output file, and it's going to map. Basically, it's going to map everything to this here. So just kind of go through, read each line, and it'll go line by line and see, okay, is it an error? And then if it's an error, we have to like match the severity of that, get the ID and get the message for each one. And then we get the location of each one, which will be the line in the column, which is the I32 thing up here with the types. And then it'll just kind of go through, and then it will finish out the report. Sorry about that. And then it'll eventually, here we go. It'll eventually close everything out at the end. Okay, so that's the runner and that's the parser. So now it just generates the report. It's very simple. You just write out the report and you print it out. So let's go into the report here, report.c. As you see, we have the severity names again, and then we return it into like a text format for the text file. These are just some like styling here. We were going to print out the summary, so this is everything that you'll see in the text file. So a lot of this is just like copy and paste. So we'll print everything out into there. So let's go into the print report. So we're just going to say static analysis report, our target, which is going to be the output file, the current time, the date, and then we will print that out. We're going to print out just a divider, print the report, or print the summary, print the correlation. That would just show like, hey, these two tools found the same thing. And then it will write the report to the actual target file. So that's the basics of a report, our reporting function for this, and that's basically our entire project. As I said, it's a very fast tool. That's what we wanted. Fast tools. That way you can just build everything, get the report, and then analyze that report. So yeah, that's our report. This is a framework SAT. Just to reiterate, it combines multiple tools, static analysis tools together, and normalizes their output, correlates their findings across these tools, and puts them in a GUI or a text or JSON based form. It's just designed to be fast and easy to integrate with development workflows. Everything here is open source, and it's going to remain open source. So the architecture is very modular. So if you don't like any of these and you have your own static analysis tool that you do like, it's very simple. Just you write a runner, you write a parser, and you just add that to the report. It's that simple. So if you want to ever contribute to this project, that's all you have to do. Just write a runner, write a parser, and add it to the report. That's been Framework SAT. Thank you for watching.